Today's lesson is applying other relationships in circles. And starting off with a theorem here, we've got if a tangent and a chord intersect at a point on the circle, point A in this case, then the measure of each angle formed is 1/2 the measure of its intercepted arc. So they're saying this angle here, because we are on the circle, angle equals half the arc. That works for this one as well, right? Angle 2. On the circle vertex, so angle equals half the arc. Angle 2 equals half ACB, or BCA, right? ACB, BCA. Angle 1 equals half arc AB, right? 3 letters, major arc, 2 letters, minor. Okay, so pretty straightforward. Next, line M is tangent to the circle. Find the measure of the red angle arc. So in this case, we've got the angle 1 is in red. Angle equals half the arc. So angle 1 equals half of 130. And half of 130 is 65. Pretty straightforward. So angle 1 is 65 degrees. Next, we've got angle equals half arc. Angle this time is 125. So 125 equals half of LJK, and we're going to multiply both sides by 2 to get 2 times 125, which is 250, equals arc LJK. Next, we've got find the indicated measure. We got angles 1 and 2 here. So angle 1, angle equals half arc. So half arc is put in here. Arc is 210. Half of 210 is 105. Now, angle 1 and 2 form a straight line. So now that we know that angle 1 is 105, we got angle 1 plus 2 is 180. Subtract 105 from each side for angle 1. Angle 1 disappears because it is 105, and angle 2 is 180 minus 100, 80. 80 minus 5, 75 degrees. Moving toward the bottom here, we got measure of angle RT. And so we're assuming this one here. I filled that in. Now again, here's why we know it's not this one. They would need 3 letters because this is greater than 90 degrees, so this is going to be greater than half the circle, right? 90 degrees would get you the semicircle. So there's 2 methods here. The first method we'll say is let's find angle x. So 180 is 98 plus x, so we're going to subtract 98 from 180 to get x is 82 degrees. And now to find RT, angle equals half arc, so 82x is half the arc. And we're going to multiply by 2 on both sides, putting 82 right there. 2 times 82 is 164, and that equals the arc RT. The other method is we could go from 98 to this arc. So I'm going to show you method 2. We're going to get the same answer. You don't need to do both, but just showing you there's more than one way to do it. So you can kind of use the other as your double check. So angle 2, 98 equals half of RST. Angle equals half arc. So times 2 on both sides, and we get 196 is RST. Now a whole circle is 360 degrees. So this arc plus this arc is a whole circle. So we can do 360 minus 196 is 164, which is arc RT. So again, similar, the only difference is we dealt with the half first here, and then we subtracted from 360 here, we subtracted from 180, and then we dealt with the half. One last part is there are 3 ways 2 lines can intersect if they intersect a circle. We can intersect inside the circle like we did in the last lesson, on the circle like we have done in this lesson and last lesson, or outside the circle. So we've dealt with 2 of the 3 cases. Now here is the third case. Right, sorry, two other cases, right? Inside the circle we are dealing with right now. Angles inside the circle, right, if we're not at the center, okay, we don't have a center point here, so it's not angle equals arc, that's only at the center. Then what we're going to do, right, it's off center, is angle 1, technically both these are equal, and then, so both arcs belong to angle 1, right? Vertical angles, this angle is also angle 1. And so how does it work? Well, to find what angle 1 equals, we're going to do half of AB plus CD, or DC plus AB, either way, and we're averaging them. So angle equals half the sum when we're on the inside. Angle 2 equals half BC plus AD, right, even though they didn't color code. Next, outside. Now they're showing three different ways this can look. Be aware, this is how it looks. But clearly the angle's on the outside, and we have lines going through or in, right? We could have secant, secant, we could have tangent, tangent, or we could have secant, secant. Sorry, this one's secant, tangent, one of each. This is two tangents, this is two secants. And all the formulas are the same. So don't worry about looking at three different ones. For outside the circle, the formula is angle equals half the difference. Now, difference, how do you know which one to subtract? The outer one, in this case, the red ones, are the larger of the two, right? So the second one, our lines intercept, is the bigger arc. So we're going to do angle 1 is half BC minus AC, and you've got to do that subtraction first. It's in parentheses. Over who angle 2 equals half PQR minus PR. Right? These form the whole circle. Sometimes that can help, but in general, angle 2 equals half PQR minus PR. And then lastly, angle 3 equals half XY minus WZ. So we're going to deal with these. Now, I've kind of mentioned the shortcuts previously. Here's how they kind of simmer down to, like just trying to make all those formulas to a couple. If we are on the circle for our vertex, our angle equals half the arc. If we are inside the circle, like this one right here, angle equals half the sum of the arcs, right? So we have two different arcs that the angle belongs to. If we're outside the circle, we're half the difference, right? Half large arc minus small arc. So second one intercepted minus the other one. So getting some practice here. We've got some on the inside, so we'll start up here. Right? We've got 102 degrees and we've got y 95. So we have three pieces, but they're not quite the three we need. So we're going to do 180 minus 102 to find this angle or this angle. They're both the same because they're vertical. And so when we do that, we get 78 degrees is these angles. And now we have two of our three pieces. We've got angle equals half the sum, and we have one of the two. So 78 angle equals half y plus 95. This is the setup. Now, after you do a couple of these, the setup won't be as difficult. However, at the beginning, it's all about making sure you use the right formula. So we're on the inside. The vertex of our angle's on the inside. Half the sum means angle equals half y plus 95. To deal with not fractions, we'd have fractions here and here. We're going to multiply both sides by 2 to get 2 times 78 is 156. Equals, and now the parentheses goes away because we don't have any numbers outside, y plus 95, and then we subtract 95 from both sides to get y is 156 minus 95 gives us 61 for y. If you plug it back in, you'll get 61 plus 95 divided by 2 give us 78 degrees. Next, we've got all three pieces we need. We've got the angle, we've got two arcs, so angle equals half the sum of the arcs. Well, we have all this right side, just plug it in. Half of 286 is 143 equals x. Next, we've got one more. This one's on the outside. We didn't have too many examples of these, but we've got angle J is 30 degrees. This large arc is A degrees, we don't know, and the smaller one is 44 degrees. So, on the outside, angle equals half the difference. So, angle is 30 degrees equals half. A is always the larger one, is the further one. A minus 44. Again, not like dealing with fractions, we're going to multiply both sides by 2 to get 60. 2 times 30 is 60 equals, now the parentheses, A minus 44. To solve for A, plus 44 to both sides, then we get A is 104 degrees. If you plug it in, 104 minus 44 is 60. Divided by half is 30. It worked. And lastly, we have a proof. Given chords AC and BD intersect, prove angle 1 equals half the sum. So this is the inside form that we're proving. I would say right now as a challenge, try to write a plan for the proof. Thinking about the steps we did in the 10-4 proof, there's a couple similar. We don't have a center, so we won't be using all radii congruent, but try to think about what we know about these. And continuing, okay, so I know angle 1 equals B and C angles added together. And then we have to figure out, well, what's angle B equal? It belongs to CD. What is angle C equal? It belongs to AB, but it doesn't equal AB because it's on the circle. Angle equals half the arc, right? So doing that, this will help us get a setup. So starting with our given, chords intersect, not much of a given. Yep. Step 2, we've got angle 1 equals angle B plus angle C. Exterior angles, right? If this is triangle, the exterior angle to the triangle is angle 1. So angle 1 and these two angles add to 180, and these three add to 180. And again, we've proved this several times. Taking away the ones that are in common, we get angle 1 equals B plus C. Exterior angles theorem. Next, what does angle B equal? Well, angle B equals half of CD or DC, because that's how it is here, and angle C equals half of AB. That is, inscribed angles equal half their intercepted arc. Now, we've got B and C. We're just going to plug them in here. Angle 1 equals half DC plus half AB. We're starting to look real close here. And that was simple substitution. And now we want to group these halves. And so we're basically factoring the half out to get measure of angle 1 equals half DC plus AB. So you can call that distribution property because we're actually going the other way. Or GCF, right? We factor, greatest common factor. And we have one last problem to do. We've got if AB and CD are congruent chords, prove that measure of arc AD equals measure of chord CB. Now notice, we've got these chords are congruent. So we've got congruent marks here. These big guys are congruent, and so the big arcs are congruent. That arc and that arc are congruent. So that's going to be our first step. AB arc is equal to CD arc. Well, what is AB made out of? Well, AD and DB. What is CD made out of? CB to BD. And now what do they have in common? They both have DB. So we're going to subtract DB from both sides to get MAD equals MCB. Now, measure of arc AD equals measure of arc CB. And that wraps up today's lesson. Make sure you check out the homework assignment on Google Classroom.